August 2025, 4:32 p.m., Friday afternoon. App development agency owner Alex Rivera was on a call with a client whose product launch was in 3 weeks. Client: Alex, we're 10 days into QA and you found 47 bugs. How many more are there? We launch in 21 days. Alex checked the QA tracker. 238 bugs logged. Still testing. We're working through them. QA typically takes 2 weeks and we're... Client interrupted. 2 weeks? We don't have 2 weeks. Every other agency does QA in 5 days. Why are you so slow? Click. 6 months later, Alex's agency would complete QA in 5 days instead of 14, ship 2 projects monthly instead of 1, and clients would say quality had never been higher, but only after AI testing found 1,000 critical bugs that turned out to be false positives, and his team wasted 3 weeks chasing issues that didn't exist. But right now, at 4:32 p.m., Alex was losing clients to faster agencies and had no idea his first solution would create more problems than it solved. He had been running his app development agency for 7 years. Quality code, happy clients. But his 2-week QA process was a bottleneck. Competitors shipped in half the time. 3 weeks later, everything would change, but not the way he expected. Part 1. The QA Bottleneck, July 2025. Alex ran a 12-person agency building custom mobile and web apps. Typical project, $80,000 to $120,000, 3-month timeline. Current capacity, 1 major project monthly. Project breakdown. Weeks 1 through 8 were development, coding features. Weeks 9 and 10 were QA and bug fixes, the bottleneck. Weeks 11 and 12 were final polish and launch. The QA process was a manual testing workflow spanning 14 days. Days 1 through 3, the QA team tested all features manually, finding obvious bugs. Days 4 through 7, developers fixed bugs while QA retested. Days 8 through 10, edge case testing on different devices and scenarios. Days 11 through 14, regression testing to ensure fixes did not break anything. The team had 2 QA engineers testing 8 developers' work. The brutal reality: developers finished coding by week 8, then sat idle for 2 weeks waiting for QA feedback. Alex could not start new projects until current QA completed because developers were needed for bug fixes. Competitor agencies completed QA in 5 to 7 days, could start new projects faster, and achieved double the project volume. August 15, 2025, 4:32 p.m. The client frustration. After losing another client to slow QA, Alex did the math. Current: 1 project per month at $100,000 meant $100,000 monthly revenue. Competitor speed: 2 projects per month at $100,000 meant $200,000 monthly. We are leaving $100,000 monthly on the table because QA takes too long. That evening, Alex researched how competitors were QA testing so fast. The answer: AI-powered automated testing. Part 2. The false positive disaster. August 16, 2025. Alex discovered AI testing tools that promised to find bugs 10 times faster than manual QA. The tools included GitHub Copilot for test generation, ChatGPT for edge case identification, and automated bug detection for visual regression and code analysis. The pitch claimed AI could test every user flow, every edge case, and every device in hours instead of weeks. Alex was skeptical but desperate. Let us test it on our current project. August 17th and 18th, 2025. The test. Alex's team set up automated AI testing on their in-progress e-commerce app. Traditional manual QA would have taken 14 days. With AI, they configured tests and ran them overnight. August 18th, 9:47 a.m. The results arrived. The AI testing report loaded. 1,247 issues flagged. Alex stared. 1,200 bugs? That cannot be right. He opened the report. Sample AI findings included: Issue number 1 flagged that button color did not meet 𝐉𝐶𝐴GAAA contrast ratio on a white background, severity marked as critical. Issue number 2 flagged that a product image loaded 0.3 seconds slower on 3G connection than on 4G, severity high. Issue number 3 flagged that a shopping cart icon appeared 2 pixels lower on iPhone SE versus iPhone 14 Pro, severity medium. Issue number 47 flagged that checkout button text saying complete purchase could be misunderstood by non-native English speakers, severity high. Alex called his lead developer over. AI found 1,200 bugs. But these are not bugs. These are design choices, performance trade-offs, and nitpicks. The lead developer responded, Issue 47 thinks our button text is a bug. This is going to waste more time than it saves. But Alex was desperate. What if some of these are real bugs buried in the noise? We need to check them all. August 18th through 30th, 2025. The Ghost Chase. Alex assigned his 8 developers to investigate AI-flagged issues. Week 1 results: 423 issues investigated. Real bugs found: 12. False positives: 411. Time wasted: 67 developer hours. Developer frustration mounted. One said, I spent 3 hours fixing issue 284. Turns out it is not a bug. It is how CSS margins work. Another said, issue 891 flagged our loading animation as inconsistent timing. It is literally designed that way for UX. August 30th. Breaking point. The lead developer confronted Alex. The AI is finding everything except what matters. We have wasted 3 weeks on false positives. Manual QA would have been faster. Alex felt defeated. AI was supposed to speed us up. Instead, we are slower than ever. Part 3. The Triage Realization. August 31st, 2025. 11:15 p.m. Alex could not sleep. He reviewed the AI bug report again, this time differently. The question, why did AI flag 1,200 issues when only 12 mattered? He sorted issues by type. Category A, actual bugs, had 12 issues. Payment processing failed when cart total equaled $0, user data displayed for the wrong account after logout, and the app crashed when uploading images larger than 10 megabytes. Category B, performance issues, had 87 issues, load times, memory usage, and network requests. Most were minor differences of less than half a second. Category C, accessibility nitpicks, had 344 issues, color contrast, font sizes, and alt text suggestions. Valid concerns, but not launch blocking. Category D, cosmetic preferences, had 804 issues, 2-pixel alignment differences across devices, wording suggestions, and icon size variations. Subjective design opinions. Alex realized AI does not understand priority. It treats a payment bug the same as a 2-pixel misalignment. It cannot separate blocks launch from nice to have. But the AI had found those 12 critical bugs in hours. Manual QA would have taken days to find the payment processing edge case. AI tested every possible combination instantly. Alex thought, what if AI does comprehensive testing, but humans categorize what actually matters? September 1st through 7th, 2025. The triage system. Alex redesigned the entire QA workflow. The new process. Day 1 involved AI comprehensive testing, automated and completed in 2 hours. AI tested all user flows, edge cases, and devices, generating a complete issue list expecting 500 to 1,000 or more flags. Day 2 involved human triage by the QA team, taking 1 full day. QA engineers categorized AI findings into 3 levels: red for critical issues that break functionality and block launch, yellow for important issues that degrade the experience and should be fixed before launch, and green for nice-to-have issues that are minor improvements for the post-launch backlog. Days 3 through 5 involved developer focus for 3 days. Developers fixed only red critical and yellow important issues, ignored green nice-to-have issues by moving them to the backlog, and AI retested fixes automatically. Total QA time, 5 days compared to 14 days before. The key insight: AI is perfect at finding everything but terrible at knowing what matters. September 8th through 15th, 2025. First test. Alex ran the new system on their next project, a fitness tracking app. Results. Day 1, AI testing completed with 847 issues flagged in 2 hours of compute time. Day 2, the QA team triage found 8 red critical issues including data sync failures and crashes, 23 yellow important issues including UX problems and slow loads, and 816 green nice-to-have issues including cosmetic suggestions. Days 3 through 5, developers fixed 31 issues total, 8 critical and 23 important. Day 5, the project was launch ready. The client responded, "This is the fastest, smoothest QA process we have experienced. When can we start the next project?" Part 4. The Architecture Revelation. October 2025 brought an unexpected benefit. With 5-day QA, Alex's agency could now ship 2 projects monthly instead of 1. October metrics. 2 projects completed, revenue of $195,000 compared to the typical $100,000, QA time per project averaging 5 days, and client satisfaction up by 34%. But something unexpected emerged in November. November 12, 2025. The pattern. Alex's lead developer noticed something in the AI bug reports across 3 projects. "Alex, look at this. AI keeps flagging the same types of critical bugs in every project. Authentication logic failures, database query errors under load, and memory leaks in image handling." Alex reviewed 6 months of AI reports. The pattern was clear. Before AI with manual QA, bugs were found late in development. Teams patched specific instances and never saw systemic patterns. After AI with comprehensive testing, the same bug types recurred across projects. This revealed architectural problems in reusable code and showed that teams were copying flawed patterns. The lead developer said, "We have technical debt in our component library. Every project inherits the same authentication bugs because we are all copying from the same flawed template." This was embarrassing but valuable. Alex called an all-hands meeting. "AI testing is showing us we have been shipping the same bugs repeatedly for years. We never caught the pattern because manual QA was too slow. Let us fix the root problems." November 15th through 30th, 2025. The architecture fix. The team spent 2 weeks refactoring core components. They rebuilt the authentication system, fixed database query patterns, and optimized image handling. The cost was 2 weeks of development time and $40,000 in opportunity cost. The benefit was that the next 3 projects had 73% fewer critical bugs. December 2025. Full transformation. December metrics per project. Development took 8 weeks, the same as before. QA took 5 days compared to 14 days before. Total timeline was 9 weeks compared to 11 weeks before. Agency capacity, 2 projects per month consistently. Revenue reached $200,000 per month compared to $100,000 before. Bug reports from clients were down by 68%. Developer efficiency was up due to less rework. December 18th, full circle. The client who had complained about slow QA in August reached out. Alex read the email aloud. "Alex, we launched 4 months ago and have not had a single critical bug reported. Your QA process was clearly worth the time. We have 3 more projects lined up. Are you available?" Alex replied, "Yes, And our QA is even faster now, 5 days instead of 14. Let us start in January. 3 projects signed for a total of $315,000. Part 5, Tools and Math. Alex's AI QA toolkit included GitHub Copilot at $19 per developer per month for 8 developers, totaling $152. ChatGPT Plus at $20 per month for test case generation. An automated testing platform at $299 per month. Total monthly cost, $471. The transformation before AI in July, 1 project per month at $100,000 revenue, 14 days of QA time, 8 to 12 critical bugs shipped per project, and monthly client complaints. After AI triage in December, 2 projects per month at $200,000 revenue, 5 days of QA time, 2 to 3 critical bugs shipped per project, and rare client complaints. Alex reflected, "Our first AI attempt found 1,200 bugs, and we wasted 3 weeks investigating false positives. We learned AI is incredible at comprehensive testing, but terrible at understanding what actually matters. The breakthrough was separating AI's job from human judgment. AI tests everything exhaustively and finds edge cases we would never think to check. Humans triage severity and decide what blocks launch. Unexpectedly, this revealed we had been shipping the same architectural bugs for years because we never saw the pattern. Fixing root causes once prevented bugs across all future projects. AI did not just speed up QA. It made us better developers." Part 6, Lessons. Lesson 1. AI finds everything but understands nothing. Alex's AI flagged 1,200 issues, including 2 pixel alignments. Comprehensive does not mean intelligent. Humans judge severity. Lesson 2. False positives waste more time than no testing. 3 weeks chasing ghosts was slower than manual QA. Triage before investigation prevents waste. Lesson 3. Speed reveals patterns that slowness hides. Faster QA across multiple projects showed recurring bugs. Alex fixed root causes, not just symptoms. Lesson 4. AI testing is a technical debt detector. Manual QA found instance bugs. AI found pattern bugs. Teams were copying flawed code unknowingly. Alex Rivera reviewing 238 bugs at 4:32 p.m. in August 2025. A client demanding faster QA, losing projects to faster agencies. A 2-week QA timeline. 1 project monthly. Clients complaining about speed. Then 3 chaotic weeks. AI found 1,200 bugs. The team wasted time on false positives, and they learned that comprehensive does not mean useful. The second approach. AI tests everything, humans triage severity, and developers fix only what matters. 6 months later, 5-day QA, 2 projects monthly, and 68% fewer bugs shipped. But more importantly, they discovered architectural problems that had been hiding for years. What changed was not their testing skills or development quality. What changed was they stopped treating all bugs equally and let AI handle exhaustive coverage while humans handled priority judgment. AI tests comprehensively. Humans decide what matters. If your QA is slow because you are trying to test everything manually, AI will not judge severity for you. But if you let AI find every possible issue, then use human judgment to separate critical from cosmetic, you can ship faster without sacrificing quality. Bugs exist on a spectrum. AI finds them all. Humans decide which ones matter.